All right, the first question on your homework is really basic. It's asking if you remember your properties of exponents. Well, now your exponents are fractions. If you had x to the second power times x to the third power, you're going to add the exponents together. So it's going to be x to the fifth power. On your homework sheet, you may have fractions as your exponents instead. So let's see what to do in a case like that. If I said x to the 1/2 times x to the 2/3, and I wanted you to simplify that, you still have to add your exponents together, only now they're fractions. So you're going to have to review adding fractions together. If you are trying to add the fraction 1/2 plus 2/3, do not just add the numerators and the denominators. That is not how adding fractions works. You must find a common denominator and make the two fractions have that same denominator. So a common denominator for 2 and 3 is going to be 6. We're going to have to multiply this fraction by 3 on top and bottom, and we're going to have to multiply this fraction by 2 on top and bottom. So that what we end up with is 3 over 6 plus 4 over 6, which equals 7 over 6. This is going to be our new exponent. So the simplified version is x to the 7 over 6 power. Okay? Another property of exponents that you're going to have to remember is when you have an exponent on the outside of the parentheses, you want to bring it in and multiply it by the exponents inside. So the current exponent on that 27 is a 1. So when we bring in the 1/3, it'll be 27 to the 1/3. The current exponent on the p is a 3. When you do 3 times 1/3, now you actually do just multiply it by the top. So this ends up being 3 over 3. Okay, this is how you multiply fractions. The slide before we did adding fractions. So to multiply fractions, you just go straight across, and then 3 over 3 is 1. So this is just going to be p to the 1 power. And then the q, which currently has a 12, 12 times 1/3 is going to end up being 12 over 3, which is 4. So this will be q to the 4th. Then I just want to simplify this answer. So 27 to the 1/3, we're looking for the number that multiplies by itself 3 times to make 27. So 3. P with the 1 is just a single p. We don't need to write the 1. And then q to the 4th. And that is as simple as this one gets. On letter B, we want to reduce the 14 and the 2, just like normal. So 14 over 2 is going to be a 7 over 1, but I don't need to show the 1 if it's on the bottom. And then those x's. I have x to the 1 on top, okay? The 1/3 is only talking about the y. So that's x to the 1 over x to the 3/4. I want to subtract those exponents, top minus bottom. So x to the 1 minus 3/4. Y to the 1/3 has nothing to combine with, no other y's in this problem. And the z to the -6 is going to come up and join the stuff on top and become z to the +6. Now there's nothing left on bottom, and I don't have to show that. I do just want to simplify the exponent on that x. So the 7 stays as it is. This becomes x to the 1 minus 3/4, which is 1/4 power, y to the 1/3, z to the 6th. Doesn't get any more simple than that. Then we're going to apply some properties of roots. Okay? In letter A here, we're looking for the third root of 64y to the 6th. I like to think about that 3, that third root, as like a guard on the porch. And he's only going to let things come out of the house or out of the root symbol if they can come out as perfect cubes or in groups of 3. So 64 is a perfect cube. It has a cubed root because the number 4 times 4 times 4 would be 64. So we are actually able to pull out a 4, okay, out of the symbol. And then the third root of y to the 6th, we're looking for how many groups of 3, or how many y cubes we can take out. And in a y to the 6th, you can take out 2 groups of 3. So when we take it out, it's going to be a y squared. And that is how you do a cubed root. Letter B, we have a 4th root. So now we're looking for only perfect fourths that can come out, okay, or groups of 4. So on the top of this fraction, we have m to the 4th. 4th root of m to the 4th is just m on top. On bottom, we have n to the 8th. We can take out 2 groups of 4 n's. So what's going to come out is an n squared. Both of these examples had perfect cubes and perfect fourths. It gets more complicated on examples like these, where you're dealing with, for example, in A, a fifth root, but all the things inside aren't divisible by 5. So we don't necessarily have perfect fifths here. So now we will have some things coming out of the symbol and some things staying inside. So I'm going to set up my fifth root. And things that come out, I'll write in front, and things that stay in, I'll write underneath the sign. So I'm starting with, from left to right here, the fifth root of 4. 4 does not have a fifth root. We can't break down that 4 at all into things that do have fifth roots. So we're just going to leave the 4 alone, inside. The a to the 8th power. I can bring out one group of 5, right? And a to the 8th, I can bring out, a to the 5th comes out, which will leave me with a to the 3rd inside. Since I'm only bringing out one group, I will write a out front. The a to the 3rd stays inside. That's the leftover a's. Okay, they didn't have enough to make a group of 5, so the guard on the porch said you have to stay in. Okay. B to the 14th, we can pull out 2 full groups of 5, which comes out looking like b squared. Okay, that's our 2 groups. And we're going to have how many left over inside? 4. Okay, they didn't make enough. They didn't have 5 b's, so they have to stay inside. And then the c's, we have one perfect group of 5, so that one group is going to come out, and it'll be a c out here with no c's left inside. And even though it's ugly, this is the correct simplified answer. And then this last one, B, is the toughest one of all. There's a couple like this at the end of your homework. I want you to try them. We'll go over them again tomorrow. What we're doing in letter B is, rather than starting by trying to look for groups of 3, I want to start by making that denominator a perfect cube. Because what we're not allowed to have, I don't know if you remember doing this earlier in the year, but if you have something like 3 over the square root of 2, I said you can't leave your answer like that. You can't leave your answer with anything underneath a root sign in your denominator. It's okay if it's in the numerator, but not the denominator. So what you have to do here is multiply the top and bottom by the square root of 2, which becomes 3 root 2 over root 4. And root 4 is just a whole number 2, right? So that's called rationalizing, getting rid of the root sign from the denominator. And that's what we need to do up here in letter B, only it's a bit more complicated. So we are looking for a perfect cube on the bottom, and right now it's y to the 8th. So we have to multiply it by something that's going to make that a perfect cube. I'm not going to multiply it by another y to the 8th, because then it'll just be y to the 16th, and that's still not a perfect cube. You get to pick how many y's you want to multiply by so that you can get it to be a perfect cube. After y to the 8th, the next perfect cube would be y to the 9th. So really, I just need to multiply it by one more y. And if I do it to the bottom, I have to do it to the top. So the top now, we still have this 3rd root. The top now is just x, y. And the bottom will be y to the 9th. And we're allowed to do that because y on top of y on bottom is really just multiplying by 1. And that doesn't change the value of this. Now we're going to simplify the top. Nothing comes out in a group of 3. So the x, y is going to both stay under the 3rd root sign. But the bottom of this fraction will no longer have that 3rd root. Because if you have y to the 9th, you can bring out 3 perfect groups of 3, and it'll just be y to the 3rd power on the bottom. And that's all you're trying to do here. You're just trying to get rid of that root sign from the bottom of the fraction. And like I said, we'll do more of those tomorrow, okay? But I do want you to try them. Those are the last 2 on your homework.